All right, so we have been working on a bunch of algebra skills and graphing, and we're about to take the algebra and put it together with the graphing so we can use them both to solve problems. So one thing we need to talk about is how all this algebra relates to the equations we've been using with our graphs. So one thing to make note of is we have looked at the equations in different forms. One of the forms we have looked at is called vertex form, and it looks like y equals a bracket x minus h squared plus k. This is an important form because when your equation looks like this, you can look at the equation and you can read off the vertex from the equation. And you do that by looking at the h and the k value. So whatever number is with the h, whatever number is where the k is, tells us the vertex. This is important because the vertex will tell us the maximum or the minimum. I think I'm spelling that wrong. There we go. Minimum value of the parabola, or in a word problem if it talks about a minimum or a maximum. The second form that we've looked at, and I don't think we've actually called it this, is standard form. And standard form looks like what you're used to seeing before you factor. Y equals ax squared plus bx plus c. Standard form is very important because it has its own use as well. The standard form is important because we can read the y-intercept directly from the equation. The reason we can do that is because the y-intercept is usually calculated by replacing x with 0. So if I put 0 in for x in my first term and 0 in for x in my second term, and when I multiply by 0, because that's what's going on in each of those terms, 0 times anything is 0. So the first term is gone, the second term is gone, and all I'm left with is a c. So that standard form tells us the y-intercept because that c number is the y-intercept. If I were to replace the x's with 0 and calculate the answer, I would be left with the c value. Oh, I'm running out of space. Let me see if I can fix that. Okay, substituted for x and calculated, only c remains. So if we put 0 in for x, and calculated an answer, we'd be left with c. So standard form tells us the y-intercept. The last form of the equation is intercept form, also known as factored form sometimes, because it's when we get our factors and all that factoring practice we've been doing. This is very, very important because if you did that graphing assignment that we just finished up with last week, you should have noticed that we can read the x-intercepts directly from the equation without having to make the graph when we know the factors. They're the numbers and the factors with the opposite signs. Oh, typo. Let's fix that. Opposite signs. Other important terms that we have thrown around with graphing: y-intercept, x-intercept, and there's a third one, but we'll get to that. The y-intercept we just talked about may calculate by substituting 0 for x. For a word problem, the y-intercept will generally tell us the initial value. So if a word problem is asking to find out where something started, you're looking for the y-intercept. And if we go back to our equations, the y-intercept goes with standard form. So whenever you see the term y-intercept, you want to put your equation in standard form. Another important term is the x-intercepts. We learned that x-intercepts can also be called roots. And we've learned that we can read them directly from the equation when it is in factored form or intercept form. Ooh, I don't know if I can fit factored in here. There we go. Intercept or factored form by numbers and the factors. Changing the signs. So when we know the factors, all we have to do is change the signs of the factors, and that will tell us our x-intercepts. Or we can calculate by substituting 0 for y, but it's much easier to know how to factor and use a pattern. In word problems, this can be referred to as a break-even point, or how long it takes to do something like hit the ground. So our x-intercepts or our roots are connected to our intercept form. So if you're asked about x-intercepts or roots, you want to make sure that your equation is in factored form. So that means you need to factor. And the last important term is maximum or minimum. The maximum or minimum is a vertex. It's the highest or lowest point. There is a minimum if the parabola opens up because the vertex is the lowest point, or there is a maximum if the parabola opens down because the vertex is a highest point. So in a word problem, it's often referred to as the highest or lowest point or value. So whenever you see the words highest or lowest, maximum or minimum, we're talking about the maximum or minimum value. And the maximum or minimum value is connected to the vertex form because the vertex tells us the highest or lowest points. So whenever you're talking about maximum or minimum, we need the equation in vertex form. So the reason we've been doing all this algebra work is so that we can actually change back and forth between those forms. And some are easier than others. So we are going to take our algebra skills, those skills we've learned about expanding and simplifying and factoring, so that we can change between those forms of equation to get the information we need without having to always make a graph. And to read it off a graph is not as accurate. So this allows us to write the equation in the form we need, depending on the information that is required for us to find. So first off, we're going to start by practicing changing back and forth between the forms. Let's get a little skinnier pen here. All right. So we are given the equation here in vertex form. There we go. If I want to change out of vertex form, I'm going to use everything I know about algebra. So the first thing I know about algebra is that if I have a bracket squared, it really just means I multiply the bracket by itself. And that's exactly what I'm going to do. And when I multiply the bracket by itself, it's a nice little FOIL question. So I have x squared, 2x, 2x. My board is doing weird things there. Plus 4 minus 16. And then we know from all our algebra that we want to collect our like terms. So I have x squared plus 4x. Those are my like terms. And those are like terms as well. 4 take away 16 is minus 12. And now, by doing all that algebra, I have my equation in standard form. So if I want my equation from standard form, I can look at that now, and I know that I should be able to factor that. I'm looking for two numbers that multiply to get negative 12 and add up to get 4. So I know that the pattern is I have my brackets, an X at the front of each bracket, and I'm looking for numbers that multiply to get 12. Well, 4 and 3 multiply to get 12. They won't add up to 4. 6 and 2 multiply to get 12. Hey, if I have plus 6 and I take away 2, that's going to add up to 4 and multiply to negative 12. So there's my intercept form. So my steps to change between. So if I want to go from vertex to standard form, the first thing I do is write out my brackets. Second thing I do is FOIL. Third thing I do is collect my like terms. And then I've got it in standard form. And then if I want to change from standard form to intercept form, I need to know about factoring. So the first thing I'm going to do is check to see if there's a common factor. Often there's not a common factor, and you can just go ahead and find out what multiplies to get the C number and adds up to get the B number. So if there's no common factor, then we can go ahead and do what I just said. Factor by determining the numbers. So you notice we needed to have, excuse me, one form to get the next. So I started with vertex. In order to get my standard form, I needed the vertex form to expand and simplify. And then in order to get my intercept form, I needed the standard form so I could factor it. So they're kind of dependent on each other. All right, we're going to do a few examples and then you're going to try some of them yourself. So let's do this first one. So my vertex form, change from vertex form, I'm going to do the algebra. So I'm going to write out the brackets and I'm going to do my FOIL. And then I'm going to collect my like terms. And now I've got my standard form. Then to get my intercept form, I need my standard form factored. So I'm looking for what multiplies to get negative 16 and adds up to get negative 6. The better you are with your times tables, the quicker you're going to figure out that it's 8 and 2. And 8 needs to be negative to add up to negative 6. And one of them has to be negative to multiply to get a negative answer. So our last step is our factored or intercept form. Two more and then we're going to take a look at those answers. All right, so I've got my vertex form. That one looks different because there's no number at the end. But it's still vertex form. Let me make that marker a little thinner. All right, so I'm going to do my algebra. And by doing the algebra, expanding and simplifying, I get standard form. And then after standard form, I can factor and I can get my intercept form. So no common factor. I'm looking for what multiplies to get 1 and adds up to get 2. Oh, this one was kind of tricky because this factored form was actually the same as my vertex form because the two factors are the same. So it's a little bit of a special case. All right, and the last one, a little more complicated because it has this crazy number at the front that none of the rest of them had. But we're still going to do our algebra. So the first step I'm going to do is write out my brackets. Now, there's a few ways you can deal with that number in front. I like to leave the number in front and do my FOIL first. So I'm going to do my FOIL first and just ignore that 2 to start with. And now I'm going to take and multiply everything from my FOIL by 2. And the very last step is to collect our like terms. So I have 2x squared minus 6x minus 80. And there finally is my standard form. Last step to get our factors. This one, however, is different because it's got that 2. It's got a common factor of 2. So I'm going to take and divide everything by 2 to start with. So common factor first. Then I can keep factoring. Now I can look for the numbers that multiply to get negative 40 and add to get negative 30. And the better you are with your timetables, the sooner you come up with minus 8 plus 5. And there's our factors or our intercept form. All right, one last comment. The reason we're doing this is to get information. And the information specifically is the vertex, the intercepts, the y-intercept, and the x-intercepts. So if I look at question C, the vertex is tricky. The vertex should be the h number and the number at the end. Well, there's no number at the end, so that would mean it would be 0. So my vertex for this question is -1 and 0. Remember, it's always the opposite sign for the h. The y-intercept comes from our standard form. So our y-intercept is 1, because if I put 0 in here and 0 in here, that'll make 0 plus 0, which is 1. So the y-intercept is 1. And the x-intercepts, look at my brackets and the opposite signs. So they're the same number, so I only have one x-intercept, -1. Okay, you're going to try some of these on your own now.